The gravitational attraction of the sun and the moon give rise to ocean tides. It is sometimes said that since the moon is closer to the earth than the sun, the moon's gravitational attraction is much stronger and therefore has a greater influence on the ocean tides. Well, is this true? To answer this question, let's think it through. To see if this is true, the gravitational attraction of moon and the sun on the earth, we should calculate using Newton's law of gravitation. For that, we need some data that we can obtain either from internet, or if you have a physics book, usually there are constants page and then so you can take it. Now what I found that the mass of the earth equals 6.0 times 10 to the 24 kilograms from my data table. Mass of the moon, M, equals 7.4 times 10 to the 22 kilograms. Mass of the sun equals 2 times 10 to the 30 kilograms. You see the order, how big difference it is? That makes sense, correct? So and then the radius of, actually the distance between Earth and the moon equals 3.8 times 10 to the 8 meters, the average distance. And the distance between Earth and the sun is 1.5 times 10 to the 8 kilometers. So we gotta be careful with the kilometers. What are we finding? We're trying to find and compare force of gravitational force between Earth and the moon, and gravitational force, let me put a little g in here so you know, gravitational force between Earth and the sun. Okay, so pretty much what we have, let's say this is our Earth, and then we have the moon, and the sun, somewhere far away. I mean, I want you to understand my drawing is not to scale. Okay, and we have the distance between the Earth and the sun. So this is our Earth, sun, and then here is the distance between our Earth and the moon. Okay, now we want to find out the force, gravitational force of attraction between the Earth and the sun. So F gravitational, Earth, sun. Here we go. Same equal F gravitational, Earth, sun on Earth. Let's put it that way. Oops, here we go. I wanted to put the vector sign. Now we have the gravitational force of the moon, a little bit larger. Gravitational, Earth, on Earth by moon. Well, the same thing will be opposite direction, but the same magnitude. Gravitational force of moon on Earth. Okay, so let's not forget the vector signs here. So we want to compare these two. Now, according to universal gravitational law, F gravity equals G m1 m2 over r squared, the r between them. Now, we want to find what is the force between Earth and the moon, little g here, that equals universal gravitational constant times mass of the Earth, mass of the moon, divided by the distance between Earth and the moon squared. Let's plug in the numbers. We have a 6.67 times 10 to the negative 11 newtons times meter squared per kilogram squared. Then we have mass of the Earth, 6 times 10 to the 24 kilograms, and this is a dot here, times the mass of the moon, which is 7.4 times 10 to the 22 kilograms, divided by the distance between Earth and the moon, 3.8 times 10 to the 8 meters squared. So this will give us a result of 2.1 times 10 to the 20 newtons. So this would be the force between the Earth and the moon. Now let's calculate the force between Earth and the sun. So F gravitational, Earth and the sun. So we're going to do the same steps. G mass of the Earth times mass of the sun divided by distance between Earth and sun squared. That equals, okay, so 6.67 times 10 to the negative 11 newtons times meter square over kilogram squared, times mass of the Earth is a 6.0 times 10 to the 24 kilograms, and the mass of the sun is a 2.0 times 10 to the 30 kilograms. Now the distance we have, that is a 1.5 times 10 to the 8, and I said let's be careful with the kilometers, so this would be 1.5 times 10 to the 11 meters. So let's put that in here, 1.5 times 10 to the 11 meters squared. Okay, so if we punch this into our calculator, it will give us a value of 3.6 times 10 to the 22 newtons. Well, what we see here that the gravitational attraction of the sun on the Earth is much greater than that of the moon on the Earth, in the order of 100 times greater. But it is well known that the moon has the major influence on tides. How is this with less gravitational attraction? Basically, it is because the gravitational differential of the moon with less gravitational attraction is greater. What does it mean? It means that the ocean water on the side of the Earth towards the moon is closer, and the gravitational attraction forms a tidal bulge. The Earth is less attracted towards the moon, but it is somewhat displaced, leaving the least attracted water on the opposite side of the moon, where another tidal bulge is formed as the moon revolves about the Earth. The tidal bulges tag along, and there are 2 high tides or bulges and 2 low tides daily. Actually, the 2 high tides are 12 hours 25 minutes apart. Even though the sun has greater gravitational attraction, the differential distances from the sun to the water, Earth's water, are minuscule, and so the sun has little effect on the daily tides. So you could actually do some follow-up exercise and that would be the gravitational attraction of the Earth on the moon provides the centripetal force that keeps the moon revolving in its orbit. It is sometimes said the moon is falling or accelerating towards the Earth. What is the magnitude of the moon's acceleration in the falling towards the Earth? And what this acceleration, why doesn't the moon get closer to the Earth? Thanks for watching. Stay tuned for more to come.